Okay, so today what I would like to do is to go over some problems that are on your dimensional analysis worksheet, and you will find this on Google Classroom. So we went through last class some different techniques you can use when you're doing dimensional analysis. So now I want to look at some of those techniques using some of the problems that are on your worksheet. So I'm going to work on a couple different problems on this worksheet so you guys can just see the process, and then I want you to do about half this worksheet trying this process. So if you look at the problem set, I'm going to look at number, let's look at number 6. So it says, what is the mass of the cereal in kilograms if we have a 40-ounce box? So in these problems on this sheet, you will not always be using just the metric system. You will be using the metric and the English system to do a lot of these problems. So if you look at the previous page, what you will see is that there's this table with different equalities that you can use to set up your conversion factors. Okay, so let's just go up to the previous page, and you can see that it's divided into different units. So here we have mass, and that's the part that we want to be using. So we have ounces and we have kilograms. So if we look at it, we have this 16 ounce is in 1 pound, but that doesn't get us all the way to kilograms. But we also have this conversion, this equality, 1 pound is 0.4536 kilograms. So we're going to be using both of these equalities to help us to set up our conversion factors. So let's go back down and go to the problem. And we have 40 ounces. So we have 40 ounces. And we want to convert this into kilograms. So the first thing we're going to be using is we're going to convert the ounces into pounds. So since we have ounces on the top here, ounces is going to have to go on the bottom of our first conversion factor. And pounds is going to have to go on the top. So if we remember from the previous page, we know that 1 pound is 16 ounces. So we're using the numbers that are next to equality on the previous page. Okay, now we're going to convert from pounds to kilograms. So let's go back up to the previous page, and we see that 0.4536 kilograms are in 1 pound. Okay, so again, we have pounds here. So pounds is going to have to go on the bottom. Kilograms is going to have to go on the top. So we have 1 pound, and this will be 0.4536 kilograms in 1 pound. So you notice here we can assume what we're given the problem is over 1. So ounces will cancel out. Pounds will cancel out. And remember, we multiply what's on the top and divide by what's on the bottom. So we have 40 times 0.4536 divided by 16. And that's going to give us 1.134 kilograms. Now I want to go over how to handle this in terms of significant figures. Now, if you can remember, there are 2 types of numbers. There's measured numbers and defined numbers. Measured numbers and exact numbers. So measured numbers are what we're getting in the problem, but remember, exact numbers can either be counting numbers or definitions. Both of our conversion factors contain definitions. No one will argue over how many ounces are in a pound. There are no estimated numbers here. And also, this is just a definition, how many kilograms are in a pound. So both of these have what we say are like an infinite number of significant figures. They are not going to drive how many significant figures are in our answer. Only the measurement and the problem will determine how many significant figures are in our answer. So we look at this and we notice the decimals present. Start from the Pacific side from the left, and we have 3 significant figures. So our answer is going to be rounded to 3 significant figures. So it's actually going to be 1.13 kilograms is our answer. Okay, so this is one of the problems. I want to go over one more type of problem here. And then you're just going to have to practice this on your own after having watched the screencast on dimensional analysis and also watching how we work through these 2 problems. Okay, on number 8, you'll notice here we have a speed of inches per second, and we have a time of 45 minutes. So we want to find the length, how long the tape is in feet. Okay, so if you think about it, if you're driving in your car and you know that you've driven maybe an hour and you know that you've gone 65 miles per hour, you know that you can take your time and multiply it by your speed, and you can find out how far you've driven. So we're going to do the same kind of thing here. We have our time and we have our speed. We can multiply these to figure out how long a piece of tape is played. Now, the problem with what we've been given is that we have different units of time. We have minutes and we have seconds. So we're going to have to first get these into the same unit of time. So the easiest thing to do would be to convert the minutes into seconds. Now, I know that all of you could easily figure that out quickly on your calculator, but again, I want you to practice using conversion factors. You guys all know how to get from one thing to another easily, but you're not familiar with conversion factors, and that is what this sheet is being used to practice. So you can check your work in other ways, but for you to get credit for this, I want to see conversion factors. So we have 45 minutes. We're going to convert this into seconds using a conversion factor. So we have minutes on the top. Think about where should minutes go in the conversion factor. It's going to have to go on the bottom for that to cancel out. Seconds will go on the top. We can think about how many seconds are in a minute. Hopefully everybody knows that 60 seconds is in 1 minute. Again, what we're given in the problem is over 1. So minutes are going to cancel out. And we know that we have 45 times 60 is going to give us 2,700 seconds. Now, I'm not going to worry about significant figures until I'm done with the problem. So I'm going to just keep that as it is. And then now we're going to multiply our time times our speed to figure out the length. So we have 1.875 inches per second times 2,700 seconds. Seconds cancel out, and we get 1.875 times 2,700 gives us 5,062.5 inches. Now we're going to get this into feet. So we know that we have inches. We can convert that to feet by saying there's 12 inches in 1 foot. So we're going to do that divided by 12 gives us 421.875 feet. Now, if we look at what we've been given the problem, we have 3 significant figures and we have 4 significant figures. So we're going to be rounding our answer to 3 significant figures for the feet. So that's going to give us 422 feet. Now we're going to convert that into meters. So let's go back up to the previous page and figure out what would help us to do that. So let's go to length, and we see that 1 foot is 0.3048 meters. So we're going to take our unrounded number, 421.87 feet, times 1 foot, 0.3048 meters. Feet cancel out, and this is going to give us 100. Again, we'll do it to 3 significant figures. It'll give us 129 meters. And those are our 2 answers. So you notice I rounded both of the answers to 3 significant figures, since 45.0 has 3 significant figures. So remember, when we're doing calculations, your conversion factors will be definitions. You do not worry about the significant figures in your conversion factors. Just use what you've been given in the problem to figure out the number significant figures with your answers. You should have all the equalities that you need on the previous page. Remember, you're just doing half of these problems on these 2 pages, so 10 out of 20 problems, just to practice. So good luck.